So this pop quiz was related to organic chemistry and MCQs. The first one, when carrying out a chemical experiment, the hazard and the risk must be considered for a given chemical. So risk is refers to potential to cause and harm. So for a given chemical, we have to check which statements are correct. Because the hazard, like example, if something is toxic, it will remain toxic, but we can minimize that. We can like risk can be minimized, but hazard will remain fixed. Like something is toxic or corrosive, so that is a hazard. But we can minimize this. How we can minimize? Like we use a low concentrations or we use a small scale experiments that will reduce the risk. So risk can change, but hazard is there with the chemical. So for a given chemical, a hazard is fixed, but a risk of using that chemical can change. In question two, heterolytic fission. Whenever the term heterolytic means when we produce ions, unequal distribution of a bond, when the bond will break, one of the element will break or take both of the electron pair. So it will produce a negative charge and a positive charge. So what will happen in the heterolytic? So free radicals, no, it will only produce ions, positive and negative, because it's an unequal distribution. As a result of unequal distribution, the one which take both of the bonded pairs, that will have a negative charge and the other will be positively charged. And free radicals are produced when there's a homolytic fission. Then we have hydrocarbon X has a molecular mass of 98. When a sample of X is shaken with a bromine water, the color of a bromine does not change. So which could be, look, bromine water, it is a test to check the presence of double bond. So because it does not decolorize bromine, means there is no double bond. So it cannot be C. Then we have to check the molecular mass is 98. So when we check the molecular mass of each of them, so C we don't have to check because it does not decolorize the bromine. So when we check the molecular mass of each of them, like here it will be, because CH3 will be there, CH2 will be there, CH2 will be there, CH2, CH2, CH2 and CH3. So 1, 2, 3, 4, 5, 6, 7. So 12 multiplied by 7 plus 3, 6, 3, 6, 8, 10, 12, 14 and 16. So it will be 16 hydrogen. So 12 multiplied by 7, that will make 84. And 84 plus 16, that will be 100. So the total mass will be 100 for this compound. So it cannot be A. Because the molecular mass is we have, according to a question, the molecular mass of a compound is 98, but this is giving 100. So when you check this one, this will be CH3. This is not there because the bromine, it does not decolorize. So CH3, CH2, 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 and CH3. Only one carbon is even this cannot be because it has one carbon more. So it is obvious that when you work out the total mass of this one, it will be more than 100. So it cannot be. So we are left with option D. So when you work out the total mass of D, this will be carbon, this will be CH2, 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 and then this is CH3. So when you work out the mass, total mass, it will come out as 98. So D will be the right answer. Which of these atmospheric pollutant is not emitted during a combustion of alkane car fuels? So nitrogen dioxide, because of like the electric spark and a high temperature inside the engine, nitrogen and oxygen So due to the high temperature, nitrogen and oxygen will react. Sulfur dioxide, the trace of sulfur is there in the fuel. The unburned carbon octane will also be there, but ammonia is not produced during a combustion of a alkane car fuels, like alkane car fuel, which is octane. So incomplete combustion or unburned hydrocarbons are there. Trace of sulfur is there in a fuel, can produce sulfur dioxide. Nitrogen and oxygen can react with each other, form oxide of nitrogen. So ammonia is a compound which is not produced in the car engines. Which of these occur in a propagation step in a methane with chlorine? This is if we have a like a methane reactor first, with what will happen, the initiation, the ultraviolet cause, this is the initiation step, how the reaction start. Then we have a propagation. So during a propagation, what will happen? Methane react with chlorine radical. As a result, it will produce a methyl radical and HCl. And then methyl radical react with another chlorine molecule, form methyl chloride plus chlorine radical. And in a termination, what will happen? How the all the free radicals combine, like chlorine radical combined with a chlorine radical, or a methyl radical combined with a chlorine radical, or a methyl radical combined with another methyl radical. So that will be the termination steps. So we have to identify which one happen in a propagation. So propagation, a molecule react with a radical. So this one, when radicals are reacting with each other, this is a termination. This is happening termination. Here, a radical react with a molecule, so radical react with a molecule, so this happen in propagation. Here, methyl radical react, this does not happen in propagation. And here, reaction of the two molecules are there, this does not happen. So that's why B is the right answer. That because in a propagation step, a radical react with a molecule. So you have to learn these mechanisms and identifying the stages. What is the iopic name of this compound? So first, because this is a geometrical isomer, so when we compare the heavy group, this is a heavy group. And when we compare the heavy group in terms of the mass, so heavy group, this one is heavy group. So whenever heavy groups are, first cis and trans are used, like why cis and trans are used when we have identical heavy groups are there. Then we use the term cis and trans, but we don't have identical, so then we have to use the term E and Z. If the heavy groups are on the same side, we use Z, and heavy groups are on the opposite side, we use E. So as you can see here, when we compare, the heavy group is there on the top, and here heavy group there at the bottom. So they're on the opposite sides of what we'll use the term E. And then even we are left with only one option, that E, and the name of this compound, like when we count the number of carbon, 1, 2, 3, 4. So second position, we have a chlorine, so 2-chlorobutene. Cis and trans means whenever we have a carbon-carbon double bond, and if we have a methyl groups are there or any heavy groups which are identical, as you can see, the when we break the from a double bond perspective, when we check, this is a heavy group in terms of mass, like 1 carbon and 3 hydrogen, and 1 carbon and 3 hydrogen. And heavy groups are on the same side. So what we use we use the term cis. If the heavy groups are on the opposite side and heavy groups are identical heavy groups. If we have heavy groups and identical heavy groups and they are on the opposite side, so we use the term trans. But if we have different heavy groups, then we use the term E and Z. Is it clear, this one?